welcome to True Projects. In this video, we are going to explain about the project that is mitigating cyber risks in smart cyber physical power systems through deep learning and hybrid security models. So before getting into the execution, first let us understand what is this project about. These days, power systems are no longer just the old-fashioned networks of power plants and wires. With more renewable energy sources like solar panels and wind turbines being used, the way electricity is managed has become much smarter. Modern grids called smart cyber physical power systems, that is CPPS, combine the physical parts like generators, transformers, and transmission lines with the digital systems that can communicate, monitor, and control the flow of electricity automatically. And this setup makes the grid more efficient and allows operators to manage energy in real time, which helps to integrate renewable and reduce waste. However, because everything is now connected and relies heavily on digital communication, the grids also become more vulnerable to cyber threats. If hackers or malware target these systems, they could disrupt electricity supply or damage infrastructure. So cybersecurity becomes critical concern. And one of the biggest challenges with renewable energy is that it is decentralized, meaning power comes from many different sources like solar panels on rooftops or wind farms scattered across regions. To keep the system running smoothly, all these devices, sensors, and control units constantly share the data with each other. But this constant communication also creates vulnerable points. So this constant communication, it creates a vulnerable points where cyber attacks could interfere. So, for example, they could inject false data, overload systems to cause a denial of service, or replay old messages to confuse the system. Such attacks can disrupt the operation of the grid, cause instability, or even damage the equipment. Because of this, protecting smart grids from cyber threats has become a major concern to ensure electricity remains reliable, stable, and sustainable. So, here this system we are proposing is designed to protect modern smart power grids from cyber attacks. So it uses a hybrid approach, combining traditional cybersecurity methods with advanced deep learning models to detect unusual or suspicious activity in the grid. So by analyzing the data with intelligent models, the system can study how different types of cyber attacks could affect the grid's operation. This helps in developing effective strategies to identify threats early and reduce their impact, making the power system more secure and reliable. So, in this project, we are using simulated data sets that are CyberThreat dataset and PSCAD dataset to train and test our models. These datasets contain examples of normal grid operations as well as artificially created cyber attacks, such as false data injection, denial of service, and replay attacks. And before feeding the data to machine learning models, so that is before using the data to train it, we will be pre-processing it and extract the important features to highlight small changes in the electrical parameters that might indicate an attack. And then we will be applying convolutional neural network model and long short-term memory model, which is LSTM, which are both the deep learning models. So these are used to analyze the data and detect anomalies accurately. So this method provides a solid way to study cyber risk and improve the security of modern smart power systems. Moving on to further improve the performance of this project, here we are using an ensemble hybrid model, which means we combine multiple deep learning models together. This helps the system to make more accurate and reliable predictions by leveraging the strength of each individual model. And here we are also incorporating explainable AI techniques that are Lime and Sharp to understand why the model made certain prediction. These tools show which features or factors are the most important, making the system more transparent and easier to interpret. This way, we can see not only what the model predicts, but also why it makes those predictions, which is very useful for analysis and decision making. And we also have developed a simple user-friendly web-based interface by using Flash framework. This interface is interactive and user-friendly, which allows users to log in securely and provide their own input data. Once the data is entered, the trained model process it and gives the prediction so users can quickly see the results without needing to work directly with the underlying code or data sets. Moving on to implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented this project. Initially, we will be importing the libraries first. So first we import the libraries, and then we will be doing data ingestion. Data ingestion is nothing but first we collect the data we need. We use the cybersecurity intrusion detection simulated network dataset from the Kaggle and load it into Pandas data frame. This allows us to work with the same data easily in Python. Then comes data pre-processing. At this stage, we clean and prepare the data. Any missing values are handled by either removing them or filling them. Categorical variables are converted into numbers and numeric features are standardized. So all values are on similar scale. If the dataset is imbalanced, we have applied smoothing technique, which helps to ensure the models that have enough examples for each class to learn properly. After that, we split the data into train and test sets, where train set is used to train the model and test set is used to evaluate the model. And we will be training all the deep learning models. Then we will be evaluating them using accuracy, precision, recall, and FN score. And we evaluate, I mean, we will check which feature has influenced that prediction by using the slime and SHAP. And we will be saving the best performing model for the future use. Coming to the front end part, we have developed a simple web interface using Flask framework where users will be able to provide input features that will be pre-processed at the backend. It will be fed to the trained model, and the trained model will be giving us a prediction. So this is how we have implemented. Now moving on to the algorithms used. These are the algorithms used in this project. These are the proposed models. And this is the ensemble model, which is an extension model. And to implement this project, we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code files. So let's open it. So these are the source code files of this project. In this folder, we have the data set that is used in this project. So let's open it. So this is the data set that we have used it. And here we have model folder in which we have algorithm information, and that will be loaded into the project code during runtime of the application. And here we have static folder in which we have files related to CSS, JavaScript, and Bootstrap files, which are important for the project's visual appeal. And here we have templates folder in which we have all the HTML templates that we will be using in this project. And it typically includes files like index.html, about.html, etc. And they will be shown in the front end. And here, these are the test cases in which we will be having different inputs that we will be giving in the front end. And here we have app.py file. So this app.py file, it contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have two Jupyter Notebook files. So these Jupyter Notebook files contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And this is the PMU dataset that we have used in this project. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now copy the path of the code folder from the address bar of the file explorer. So copy it. Now open Anaconda prompt. It is open. Give the command cd, give the space, paste the copied path, and click on enter. Here you can see current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So just wait for a while. It is being compiled. So this is the address where application has been hosted. So copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get registered first. So you can click on register or you can click on get security assessment. So let's click on register. And here you need to create an account. And for creating account, you need to fill in all the details. I have already created, so I'll directly sign in. Click on sign in. So give your username and the password to sign in. And now click on sign in. So we have signed in successfully and redirected to this prediction page of this project. So this is the prediction page of the project. And here we will be doing prediction for both the data sets, that is PSCAD dataset and cyber threat data. So for PSCAD, we will be uploading the dataset file, and for cyber threat, we will be we will be just giving the parameters. So let's click on PSCAD data. And here you can see a choose file button, right? We need to click on that for uploading the dataset file. And that file should be in the format of CSV, JSON, XLS, that is .xls or XLS, and it should not exceed the limit of 10 MB. So let's click on choose file. So select the test data that we are supposed to upload. So I'm selecting the PSCAD test data, click on open, and now click on analyze file threads. So click on it. So this given file will be pre-processed at the backend. It will be fed to the train model, and the train model will be giving us the prediction. So here total records that we were given as input is 94 records. From that 34 were safe and 60 threat has been detected. And the threat rate is 63.83% from the given 94 records. And here you can see the prediction. So here are the multiple parameters that we have given for each test case. And for each test case, we have the prediction, that is attack detected as well as there is no attack. So here you can see multiple parameters have been given. So here you can see prediction as attack detected and no attack detected. See here you can see there is no attack. So in this way, just by uploading file, you will be getting the prediction. So we can even download the results. That is, this file will be downloaded. The result file will be downloaded. So we're done with uploading the file. Now let's check with the other data set prediction, that is cyber threat data. So click on it. So here you can see multiple parameters which are need to be given as input. So let's understand what are these. First we have is the L4 source port. This is the source port number at the transport layer. It identifies the application or service on the device sending the data. Then we have L4 destination port. It is a destination port number at the transport layer, and it identifies the application or service on this device receiving the data. Then we have protocol. It is the network protocol used in the communication such as TCP, UDP, or ICMP, and it determines how the data is transmitted between the devices. And here we have L7 proto. It is the application layer protocol like HTTP, FTP, or DNS, specifying the type of the application. Here we have incoming bytes. So it is the total number of incoming bytes received by the device during a connection or a flow. Then we have outgoing bytes. So it is the total number of outgoing bytes sent from the device during the connection flow. Then we have incoming packets. It is the total number of incoming packets received by the device during the flow. Then we have outgoing packets. It is the total number of outgoing packets sent from the device during the flow. Then we have TCP flags. So it is the special control flags in the TCP packets like SYN, ACK, FIN that indicate the status or purpose of a connection. Then we have flow duration ms. That is the flow duration milliseconds. It is the total duration of the network flow in milliseconds, showing how long the communication is lasted. So this is all about the parameters. Now let's enter them. So let's open test cases. Open test cases and open this cyberthreatdata.csv. So here we have the target column that we will be predicting. So we will not be giving this column as input. So let's check with injection attack first. So apply filter to it and click on OK. So now let's start entering the values, where L4 is 46808 and L4 destination port is 80 and protocol is 6, L7 is 7 and incoming bytes are 482 and outgoing bytes are 2239. Incoming packets are 5, outgoing packets are 6, TCP flags are 27 and flow duration milliseconds is 145. Now click on predict attack type. So here we got the prediction that it is injection attack, and here we have confidence score that is 100%. And here we have risk assessment that is high, and here we have potential causes of the injection attack, which is malicious data injection detected in network traffic patterns, potentially compromising system integrity. And here we have recommendations for that. Let's try to analyze another sample. So let's apply filter to MITM. So apply filter, click on OK. And let's check with the first case. So let's give the source port as 60641 and L4 destination port is 5317, and then L2 protocol it is 5 108 108, then 2 2 0 4. Click on predict attack type. And here we got the prediction. It is MITM attack. And here we have confidence score, risk assessment, and potential causes of MITM attack. Let's check with the other sample. Click on another sample. So let's apply filter to replay attack. Click on OK. And let's check with this case. So where L4 source port is 56356 80 6 7 4 5 8 2 1 6 3 5 5 27 1528. Click on predict attack type. And here we got the prediction. It is a replay attack. And here we have confidence score, risk assessment, potential causes of replay attack, and the recommendations. Let's try with the last sample. So let's apply filter to spoofing attack. Click on OK. So let's check with this case. And let's give L4 SRC port, that is 38524 53 17 5 100 100 2 2 0 5. Yeah, we're done with entering all the inputs. Now let's click on predict attack type. So click on it. And here we got the result. It is a spoofing attack. And here we have confidence score, risk assessment, potential causes, and the recommendations. So this is how you need to do the prediction. Now let's check with the graphs. So click on graph, click on PSCAD data first. So here we have the sample outcome. So here on x-axis, we have the targets that we are predicting, and on y-axis, we have count. Close it. And here we have confusion matrix and ROC AUC. So this is the confusion matrix and this is ROC AUC. And here we have accuracy score comparison graph. So here on x-axis, we have all the models that we have trained, and on y-axis, we have accuracy score. And here we have precision score. So this is the precision score comparison graph. This is the recall score. And here we have FN score. And here we have SHAP, that is XAI SHAP graph. So this is the XAI SHAP graph. Now let's check with the other graphs. So click on cyber threat data. So here you can see graphs for the cyber threat data. So here on x-axis, we have all the class labels, and on y-axis, we have count. You can see MITM attack count is very less. So after applying smoothie technique, here is the balanced class distribution. And here we have confusion matrix, ROC AUC curve graph. And here we have accuracy comparison graph. And here we have precision score comparison graph. Here we have recall score. And here we have FN score. Similarly, here we have XAI SHAP graph. Close it. Now click on logout. So in this way, just by giving required inputs to the application will be accurately predicting whether there is cyber attack in the smart power systems or not. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.